Cool. So thanks everybody for joining. Today we have two sessions. So I'll be having a lightning talk talking about common use cases and some lessons that we learned from leveraging IoT for utilities and mining. My session would be quick, probably between 10 and 20 minutes. And then there is more exciting session that Shane will tell us all about his journey with IoT. So with that, let's get started. Probably a bit about me. I think I know most people on the call, but probably there are a couple that I don't know. For those who don't know me, I'm Altaiar. I'm a director at VNext. I'm also a Microsoft Azure MVP. I'm also an MVP for AI as well. I focus on IoT, data, and DevOps. Been doing a fair bit of IoT for the last 5-6 years. Worked with a number of utility companies across the country. Did IoT for mining, for health, for other domains as well. I'm also one of the organizers for the Melbourne Azure Meetup, along with the awesome James. Here is just my contact details if people want to get in touch. And before I get started, it would be a miss not to mention that we are hiring. So if anybody interested, if you are looking for a change, or if you are interested in IoT, advanced analytics, and the likes, please ping me and let's have a chat. Okay, enough about myself. So let's start talking about IoT. Probably worth talking about what makes IoT so special. A lot of people think about IoT as very innovative, cutting edge. Some people think about it as just an integration project. So I thought probably worth just telling you about what makes it different. You could break IoT projects into really 3 small steps or 3 small components. There is a thing, there is a device, there is a data point that's coming, could be from an app, could be from a sensor, could be from anywhere. That data point hopefully helps us in identifying a pattern or create an insight. That insight drives an action. The same pattern across all IoT projects. A few characteristics that are really specific for IoT projects. There is always the expectation that there is very high volume of data throughput, or very high data throughput, I should say. Usually the sensors or the things or the device that you are working with are very constrained in terms of hardware and capability that they have. Security is a really tricky one, very challenging for IoT. Connectivity is another challenge, and then power supply. I'm not going to cover the first 2 because they are kind of common knowledge, but I'll give examples of the last 3. So when it comes to security, it's a real pain, it's a real challenge in IoT. If you are doubtful or skeptical, here are 3 common examples or recent examples. The first one in Mirai, where hackers breached IoT devices and then launched a distributed denial of service attack on the East Coast of the US, which rendered the whole East Coast offline for a period of time. Another example, there was a data breach where hackers got access to a fish tank in a casino, and then from there they penetrated the network. And the last example, Triton, where hackers infiltrated critical infrastructure. The key point that I'm trying to make, it's really tricky and it's really challenging to secure IoT projects. You don't have your firewall sitting in front of it. You don't have your identity integrated with your identity provider, integrated with your devices. You could have devices that are in the wild, that are moving around. So it's not as easy as securing your applications or your data platforms. The other part that is challenging, we will look at the challenges of power supply, but a lot of the time, because of the constrained nature of the hardware that you are running, along with limited power supply, you try to make trade-offs on how much encryption and how much security you're going to take to give you longer battery life. So security, connectivity is another challenge. There are so many protocols, communication protocols that are available out there. I haven't used all. I've used quite a few of those. Most people will be familiar with HTTP. AMQP probably will be a few people familiar with LoRaWAN, MQTT. IoT Hub out of the box supports these three, so IoT Hub, AMQP, and MQTT. But in reality, a lot of the sensors and the constrained devices, they might not really support any of these. MQTT is quite good with energy efficiency, but there are devices that can even run MQTT, or they can't run the SDK from Azure IoT Hub. So it's quite tricky getting interoperability between these sensors, and that's a common problem for IoT. The other challenge, if you have used any SaaS offering, or if you are using any provider, say telco providers or otherwise, then you have on top of this, you have your business-to-business integration, which is another layer of fun. And the last challenge is power supply. Things that we take for granted when we are building applications or we deploying into a server. You have power there. You don't really think about it. But when it comes into IoT devices, a lot of the things or the devices are mobile or disconnected, so you don't have enough power. Or if you have power, you might have a battery, but then the battery is expected to last 5 years, 10 years. So you can't really have that robust, reliable connections. You can't sync data as much as you want. So there are trade-offs always that you need to make. And again, because of the limited power supply, sometimes you have to make trade-offs on how much security you wanna put in there, security measures, I should say. Some of the common use cases that I have been involved in, I'm sure there are a lot of other use cases that people have seen. Rollout of digital meters. You notice that I'm putting a digital meter for water. Pretty much all electricity providers had to switch into digital meters a few years back because of the legislation changes at the time. But a lot of the water networks are still using analog and old technology. So many of the water supply or water authorities are switching into digital meters. Even the energy suppliers are optimizing and making changes based on regulatory requirement or otherwise, and they have to make changes with the digital meters as well. Digital meters and other digital assets will enable predictive maintenance, and it's a key driver for a lot of organizations. Safety drivers, especially in mining, safety and the ability to reduce downtime is really strong driver for many of the projects that I have seen. And digital twin, where you create a digital replica of your real world, and then it allows you to do AI and fun stuff on top of it to create optimizations, find anomalies and things like that. So some of the lessons, I have probably 4 or 5 lessons. Probably for full disclosure, you're not going to find anything that is extraordinary. Most of it is common sense and probably applicable for other fields, not just for IoT. But this is really what I have observed from my experience over the last 4 or 5 years. The basic one and the most basic one is really starting with the business value. A lot of the IoT projects that I have seen, they start with a proof of concept. They try to boil the ocean. They're trying to work with the latest technology or try to test too many technologies. But then some of these projects fizzle or they fail or they go over budget. Starting with the business value, what's really going to add business value, and just delivering just that small piece first, and then from there scale. Obviously, you need to think about architecture on long term, but then maybe starting with that small one. This, in my view, along with buying from leadership, is one of the main really reasons why many IoT or AI projects fail, because people trying to boil the ocean from day one. Lesson 2, design for change. Everything is changing. So start with a solid hardware that would help you build that long term and allow you to extend and take advantage of changes that are coming after. Don't pigeonhole yourself into one particular protocol. I've worked with startups or organizations where they are really supporting one protocol, and then a year or so later they find there are other scenarios that they can't do with particular protocol, or because of latency or otherwise, they have to adapt or change. And sometimes you don't make the decision on the protocols based on what products you are using. So depending on sensors or device that you are using. Third one is hardware. Make sure, I think I mentioned it before, make sure that you are using a solid hardware base. I worked for a startup, or I helped a startup before. They were really ahead of the market. They were in the entertainment sector. They were really ahead of the market by probably 2 years, but they made a poor choice with the hardware that they were using is an old microcontroller. And as we tried to add more features, we're hitting limitations with that. And when they made the decision to switch into a different hardware component, then we were probably went backward by probably close to 6 months or a year, because many of the components you can take and migrate straight away with the embedded software, especially when we are talking about better hardware, maybe the ability to use SDK. So we can't really take all the stuff that we had before. If you have the luxury, maybe look at using Azure Sphere or Azure Percept. It would help you with choosing a good hardware to start with, but also it would help with security as well, because these two devices, actually Azure Percept is built on top of Azure Sphere. They have security embedded as part of the chip design, and they have services with their Microsoft that would do patching or alerts for any security breaches as well. The fourth one, which I think I alluded to before, openness, keeping your options open, being able to support multiple protocols. Otherwise, you might find yourself that you are forced to support one where your architecture might not support it. And the last one is moving as far up the stack as you can. It sounds like really common sense. One recent customer that I was working with, they have the ability to ingest data just through IoT Hub. For whatever reason, they were convinced to use a VM and have an agent sitting there and ingesting data. As we started scaling, obviously there are issues with VM, and it's not just that you can't scale, but then the cost and the maintenance behind it and the patching and all that, it makes it really challenging. So my recommendation to my customers, and this is what I'm saying here, is move as high up the stack as possibly can. You possibly can. Azure IoT Central is a SaaS service that you can take advantage of, or you could use past services like Azure IoT Hub and Stream Analytics. So with that, I'll wrap up. Here are my contact details if anybody want to have a chat or want to get in touch. Is there any questions before I hand over to James and Shane?